So today we're going to talk about difference of squares and perfect square trinomial factoring. So the first thing we're going to focus on is factoring a difference of squares. If you recall, the product of two conjugates results in a difference of squares. Now conjugates have the same terms but different signs. So you've got a plus b in one parentheses and a minus b in the second parentheses. Well, when you multiply those together, you just get a square minus b squared. Now, what we're going to do is we're going to go backwards. We're going to take what's in the box and we're going to break it up into its binomial factors. So we're going to reverse that process. Okay. Now, the factored form of a difference of squares, remember this is a subtraction of two squared terms, equals to the conjugate of those terms once you square them. The sum of squares is prime. A squared plus b squared is prime over the set of real numbers. So it has to be a squared minus b squared or you cannot factor it. So this one says what is or what binomial factor is 2x minus 3 and 2x plus 3. So if I take my 2x and I square it, and I subtract my 3 squared from it, that gives me 4x squared minus 9. That is the binomial that I get from multiplying those two conjugates together. Now, we're going to undo that. So to factor the binomials completely, we're going to break it down into its squares. So I have y squared minus 7 squared, which would give me y plus 7 and y minus 7. In the second example, or example 3, I should say, we've got 3s squared. Then we're going to break that up into the squares, which is 5t squared. So I have 3s minus 5t and 3s plus 5t. Those are the factors of that binomial. Now, number 4, I apologize, we haven't run across that yet because we have a greatest common factor of 2 that we need to address. So we're going to pull out the 2, and that leaves me with 25 minus d squared. Now, my final answer is going to look like this, a 2 with 2 binomial factors behind it. So I'm going to break up what's in the parentheses. So I have 2 times 5 squared minus d squared. So that would give me a5 plus d and a5 minus d. Now notice here I put the plus first before the minus, but over here I put the minus before the plus. It really does not matter. In this particular answer for number 4, I could have put 5 minus d in the first group and 5 plus d in the second group. Does not matter as long as you have those conjugates, 1 plus and 1 minus. Now, it's okay in number 5 to have multiple variables. So we're going to break this up into 8xy squared minus 1 squared. So that's going to give me 8xy plus 1 and 8xy minus 1. Number 6 is special, so I'm going to put an asterisk by it because this is what I call a double difference of squares. When I break this down, I get h squared squared minus 9 squared, and that gives me the binomial factors h squared plus 9 and h squared minus 9. Now, this is where the double difference of squares comes in because I can break that one down further. So the first parentheses, which is a sum of squares, I cannot do that while I'm working with real numbers. The second set of parentheses, I can actually break down into h squared minus 3 squared. and that will give me the sum, h squared plus 9, and then the conjugates, h plus 3 and h minus 3 as a final answer. So I had to do the difference of squares here. That's the first round. And then I had to do the second round here. So be very, very careful. The only time you have to do the double difference is when your exponent is bigger than 2. Now, this is prime because this is a sum of squares, and we cannot factor a sum of squares over the set of real numbers. So we cannot do anything with number 7. All right. Now we're going to go back and review factor by grouping, because we are going to, you'll always have to go through factor by grouping, but these factor by groupings also incorporate a difference of squares amongst it. So we're going to group the first 2 terms together, group the last 2 terms together. I'll take out an x squared from the first group. That leaves me with x minus 3. I take out the negative 4 because that leading number is negative. That leaves me with x minus 3. So I end up with x squared minus 4 and x minus 3 as my factors. Now, this is a difference of squares. So I have to break that down. That would become x plus 2, x minus 2. Those are my conjugate factors of that difference of squares. And then I have x minus 3. So my final answer has 3 binomial factors as opposed to just 2. Same thing for number 9. We're going to group the first 2 and the last 2 together. So from the first group, I'm going to take out an x squared. That leaves me with y squared minus 1. Then I'm going to take out a y squared from the second group, and that leaves me with a y squared minus 1. So to begin with, I get x squared plus y squared, and then y squared minus 1. Now, the first parentheses, that's a sum of squares. You cannot do anything with that. Sum of squares, that just kind of stays. But this is a difference of squares, so I am going to have to break that down, into its conjugate factors. So that would be y plus 1 and y minus 1. That's what I get as the conjugate factors for y squared minus 1. Now, a perfect square trinomial. You can factor a perfect square trinomial just like you would any other trinomial. The only difference is both of your factors end up being identical. Okay? Now, there is a shortcut. If you want to learn the shortcut, that's fine. I usually just do typical factoring. Okay? So, if I were to multiply this together, I would just do 3x minus 4 times 3x minus 4. And I would FOIL that out, just like you would. Notice in the middle, my first term gives me 9x squared. I get a negative 12x, but then I get a second negative 12x, and then the plus 16 at the end. So I get the same 2 middle terms. Okay, so I would end up with the trinomial 9x squared minus 24x plus 16. Now that's how you FOIL something, a binomial that is squared. You write it down twice and you FOIL it out. So we're going to undo that. We're going to go backwards. Okay, so I'm going to ask you, which one is the perfect square trinomial? Well, the factors of 9 that add up to 6 are 3 and 3. They just so happen to be the same exact number. In this case, the factor of 9s that add up to 10 are 1 and 10. So this is not a perfect square because 1 and 10 are not a repetitive number. So I apologize, I went too far. This says factor the trinomial in part A. So we're going to factor that one. That would be x plus 3 and x plus 3. Or you can write it as x plus 3 squared, since there are two of them. When you factor the second one, you get x plus 1. I apologize, that's a 9, not a 10. And x plus 9, which I cannot write in that format, okay? So that is why this one is considered a perfect square trinomial and this one is not. So always look for the pair for the perfect square trinomial. Factors of 64 that add up to 16, 8 and 8. So I get a minus 8, or I can go to a minus 8 squared. Now remember, my C value is positive, so I have to use two negatives in this one because my B value is negative. Now, in number 13, it's a little bit trickier because we do have this number in front. So I'm going to do the AC method. When I multiply 9 and 25 together, I get 225. And the factors of 225 that just so happen to add up to my B value are 15 and 15. Now, a good indicator to me that that might be the case is the fact that my A value is a perfect square, 3 times 3, and my C value is also a perfect square, 5 times 5. So if you notice, 3 times 5 gives me the 15. So when I break this down, I'm going to break up the squares. 3x, that's my squares, 5, and since all things are positive, I would have two plus signs in my binomial factors. So 3x plus 5 squared would be my final answer. All right, now the shortcut version to that is to use the formula that they gave you all the way back up here, okay? And I'm going to show you how this works. Now, since I noticed this is a square, I can write that as 3x squared plus 2 and then plus 5 squared, since my first number and my last number are squares. Now, to get the number in the middle, to get that 30x right there, I need to take the 3x and the 5. If all of this multiplies up to 30, then I have a perfect square, and I can write it as 3x plus 5 squared. Well, 2 times 3 is 6, and 6 times 5 does indeed give me 30 in the middle. So therefore, my answer is 3x plus 5 squared. Okay, now I'm going to backtrack, and I'm going to do the first one that way, because there's always a pattern. So this would be a squared plus 2, I need two parentheses there, plus 8 squared. If your first term and your last term are not perfect squares, this method does not work. So I'm going to put an A here and an 8 here. When I multiply all this together, if I get that middle number, I'm good. Now, right now I have the positive, but I'm going to take that out and I can put a negative there, because we already talked about if C is positive, you have to look here to decide what sign you use. So that's where I can come up with using the shortcut to get a minus 8 squared as opposed to going through some of the other methods. So I'm going to do number 15 before I do number 14. So when I look at number 15, I get 3x squared plus 2 with two parentheses plus y squared. So I'm going to put my 3x and my y here. As long as this adds up or multiplies up to that middle term, then I have my factors. If it does not, we cannot use this method. Okay. Now, the reason I skipped over number 14 is because number 1, it's not in order. So the first thing I need to do is put the terms in the proper trinomial order. Now, the second thing is that I have a difference or a greatest common factor. So I'm going to take out the 2. And then from there, I'm going to see I have a d squared minus 2 and my 2 parentheses plus 5 squared. Now, when I put my d and my 5, if all of this equals to negative 10, then I can factor it. Now, do not forget that greatest common factor. So I end up with d plus 5 squared with that common factor of 2 out in front. 2 more, 16 and 17. So here I have 2x squared plus 2 times, I need my 2 parentheses, plus 5 squared. I'm going to put a 2x and a 5 here. If this multiplies up to 25, I'm good. Now, if you notice, that does not give me 25. That gives me 20x. So this is not a perfect square trinomial. But what I'll need to do is see if I can factor it a different way. And if I can't factor it using one of the other methods, then I will just simply say that this is prime. But this is not a perfect square trinomial because 2 times 2 times 5 does not give me 25. So just because my first and last term are perfect squares does not mean that they are all perfect square trinomials. So we're going to do the AC factor by grouping method. So we're going to multiply 4 times 25. That gives me 100. Factors of 100 that break up into 25 are 4 and 25. I apologize. Apologize for that. It would be 5 and 20. The factors of 100 that add up to 25 would be 5 and 20. So I'm going to rewrite this as 4x squared plus 20x plus 5x. If you did not watch the greatest common factor factor by grouping, please do so. These two group together. I pull out the 4x. That leaves me with an x plus 5. When I group the last two terms together, I pull out a positive 5. And that leaves me with an x plus 5. So my factors are 4x plus 5 and x plus 5. Clearly not the same set of binomial factors. So just because my first term is perfect square and my last term is a perfect square, if that number doesn't, if that combination 2 times the a and b do not add up, then it's not a perfect square trinomial. But that does not mean that you can't factor it in some other format. All right, so now the last one, number 17. First of all, it's not in correct order, so we're going to write it as 27s squared minus 36s plus 12. We do have a common factor of 3, which leaves me with 9s squared minus 18s plus 6. Plus 4. And now I need to see if I can factor the trinomial. So that would be 3s squared minus 2, my 2 parentheses, plus 2 squared, which is 4. I'm going to put a 3s here and a 2 here. If all of this adds up to negative 18 or multiplies up to negative 18, we're good. 2 times 3 is 6. And, well, if your math teacher could do the right thing, 36 divided by 3 is 12, not 18. This number does add up or multiply up to 12. 2 times 3 times 2. I apologize for the mistake. So now I have 3s minus 2 squared as my final answer. Do not forget your GCF at the very beginning. If you have any questions, please make sure you ask. And here again, I apologize for the couple of little mistakes that I made along the way, but they are corrected now.